Alright guys, welcome to section 2.4. This is the cosine law. Okay, so with cosine law, um, we can use this when sine law isn't applicable. Um, if you have a choice, I tend to like sine law better, but cosine law works just as well. You can use cosine law whenever you are given an angle and the two adjacent sides, or if you're given all three sides to a triangle and need to find an angle. So with cosine law, so with cosine law, if you got a triangle A, B, C, the law is just A squared equals A squared equals B squared plus C squared minus 2BC cosine angle A. So basically all you need is just any angle and then the two adjacent sides. And that will let you find the opposite side of the angle. Okay, so these letters are actually interchangeable. It could be c squared equals a squared plus b squared minus 2ac times cosine of c. All that matters is that you have the proper sides in and the right angle for cosine A. Or if we're looking for an angle, you would be solving for cosine A. In that formula, if you were to rearrange this formula looking for um, angle A, that would be cosine -1 of a squared minus b squared minus c squared, all divided by -2bc. Okay? Now, on the test, I will give you this formula here. If you want, you can memorize this guy over here. That's up to you. Or you can just plug everything in and solve for big A on your own. It's up to you. You will not be given this formula here on the test. So let's go through and do a couple of examples. It's fairly straightforward. And if you have taken Foundations 20, then this is kind of just a quick review class for you guys, so it should be straightforward. All right, so we want to find this length here for example 1. That's my little a. So a like so. So I'll just go ahead and plug in some values for that. So equals 3 squared. We'll just do this consistently just so there's no confusion. So side B is 6 squared plus 3 squared minus 2 times 6 times 3 times cosine of 36. Now, this here, this 2 times BC cosine A, that's where most people make the mistake. All right, you have to multiply all of this together. So I'll do this first example. I'll show all of my work so you guys can see everything and go from there. Okay, then it's up to you. I'll start skipping some steps just because I don't feel like it's necessary to show you all of the math. You guys should be able to figure quite a bit of this out for yourself. So first thing I like to do is I just like to work out some of these numbers. So a squared equals 36 plus 9 minus 2 times 6 times 3. That is 36 times cosine 36. This is just by coincidence that we're getting a lot of 36s here. Normally it doesn't work quite like that. Equals 45 Now, if you're skilled enough, you can plug all of this into your calculator at once actually, and it'll do it. You just have to make sure you're punching it in properly. Otherwise, I kind of do it in steps just to make sure I'm doing it correctly. And I kind of do it in these steps here. The next thing I'm going to work out is the 36 times cosine 36. And that works out to be, and I usually go to 2 decimal places just to keep it somewhat accurate. So then 45 minus all of that. And then in the end, so I have a squared equals 15.87. So I take the square root of everything. And I get an answer of a equals 3.98, or you could even just put it as 4. Okay? And that's the answer for this guy here. And that's how you would do that. So make sure you go through and do these examples, because like with sine law, setting them up isn't so bad. It's just doing the calculations with your calculator people take for granted, and it's where you can tend to make your most mistakes. All right, so let's move on. All right, so let's look at this word problem here. So we have 2 ships set sail from port P. All right. The first ship sails 7 kilometers to point R, and the second ship sails 8 kilometers to point Q. The distance between R and Q is 13 kilometers. Determine the angle between the direction of the 2 ships. So if we have R, whoa, over here, and let's put Q now over here. So ship 1 went this way towards R. We'll say that's 7K. Ship 2 went over to point Q, which was 80 kilometers. And we know the distance between them is 13. We want to determine the angle between the direction of the 2 ships. So one ship went towards R, one went to Q, so the angle would be here. So we're looking for an angle P. Okay, so when dealing with this, all that we need to know is if this is the angle we're looking for, then this side over here would be our little A side. And these 2 other sides, it doesn't matter which one's B or C, that's kind of interchangeable here. So, but I'll just say this is B, and then this would be C, even though I'm dealing with P, Q, R. The letters really don't mean anything. They could be rainbows and unicorn symbols and, pots of gold. It doesn't matter. It's just these are the placeholders that we're using, our variables, okay? So I'm going to set this up. Like so. So this is what I'm looking for over here, the big A, or my P. So if I plug everything in, like so. Just erase some of the stuff that keeps popping up with my pen. All right, so this is everything I have. So now, what you need to do, the biggest mistake that people make is when they're solving for cosine A, is they think that they can add the 2 times 7 times 8 over to the other side, and you can't. This is all being multiplied. So when you bring this over, you have to divide it. So I'm going to do this. I'm going to just move everything over in one step and just show you the algebra. If you want that formula I wrote down over here on the first page, you can just fill that in and go from there, but I'm just going to show a little bit of math and then solve it. So it's going to be 13 squared minus 7 squared minus 8 squared divided by negative 2 times 7 times 8. And that's going to equal cos of A. Okay, like so. So I'm going to work this all out. 13 squared is 169 minus 49 minus 68. That's 56. All over negative 2 times 56, so that would be negative 112. 56 divided by negative 112 is going to be a half, negative a half. So then you need to determine where cosine is negative 0.5. Now you can use your calculator, or if you really wanted to razzle dazzle me, you could use, the known trig values that we used the other day, which would be really cool if you looked at and thought, okay, where's cosine negative? Well, that's in quadrant 2 and quadrant 3. Now, it won't be in quadrant 3, right? Because that's bigger than 180 and we're dealing with a triangle. So we know we're dealing with a cosine value here in quadrant 2 because that'll be negative. And if you use your reference angles, you know that cosine of a half is actually 60. This would be 120. So if you figured this out, you know your A value is 120. There. Okay. But you can just use your calculator and go cosine negative 1.5. Gives me that. Or you could do that. If you did something like this on the test and showed me that, I would probably give you bonus marks because that's pretty cool. All right, for this next example, I'll help you guys set this one up, and then I would like you guys to give it a go. Um, try it on your own, and I'll just put down the answer afterwards. All right, so we're going to draw this one out real quick. So we have a retaining wall, which is leaning at an angle of 70 degrees to the horizontal. So if you have a horizontal, it's going to be shaped like that. It's just straight ground. Normally you want your walls at a nice 90-degree angle to the ground, but this one's starting to lean, like so. That's at 70 degrees. Now they're going to take a support to keep this wall up, and it's going to be placed 5 meters from the base. So they're going to take a support, push it up against the wall like so, hold it there. And that's going to be at 5 meters from the base. And it will be attached to the wall 2.5 meters from the wall's base. So that means from the wall's base up to the support is 2.5 meters. Look at that. This is shaping up to be a question that we could use cosine law. We wanted to determine the length of the support to the nearest tenth of a meter. So we want this guy here. And the measure of the angle between the support and the wall to the nearest degree. So we need to find two things with this one. With this guy here, uh, surprise, surprise, we're going to have to use cosine law first to solve for this side here. Okay? So I want you guys to try that one on your own. I'll pause the video and then I'll put the answer up here when you give it a shot. All right, so I worked it out. I set it up. This is my B, this is my C, and this is my big A. I work it all out. I get 4.8 meters. Now I just need to solve for this angle here. So that's going to be sine theta. I'm going to use sine law for this one because I have an angle and its adjacent side now. So I'm going to use sine law because I find it just a little bit quicker to use. And it doesn't stipulate in the question which formula I need to use. And on an exam or anything like that, I'll never specifically say you must use sine law or you must use cosine law. The question will just be conveniently set up where you have to use one or the other, or you get a choice. So now, this is just a quick review from the other day. So it's 5 times sine 70 divided by 4.8. All right, so here's the answer for the retaining wall. So what I did is I used cosine law first, and I worked out for the side of the retaining wall. I then went back and used that information and set up sine law here to find the angle between the retaining wall and the brace, and it gave me an answer of 78 degrees. So hopefully you got that. All right, so here's some stuff on bearings. Whenever you're dealing with bearings, it's like dealing with compass directions, but we measure everything off of north and we go clockwise. So if I gave you a bearing of 60, I would measure 60 degrees off of north in the clockwise direction, right? And that would give me, I could say that's a bearing of 60, or I could say that's north 60 degrees east. Or if I said a bearing of 240, let's redraw that line. This is 240 degrees here, or it's also 60 degrees off of south, right? Because from north to south is 180, plus 60 is 240. So I could say it's a bearing of 240. I could say I'm going south 60 degrees west. And then here's a big one of a bearing of 340. So I go clockwise from north all the way around to 340. And that leaves me 20 degrees short of going completely around. So I can measure off of north, and that would be 20 degrees north, or north 20 degrees west, sorry. And there's how you would do bearings. Okay, so let's move on to the last example now. All right, so for our last example here, we're going to deal with bearings. Surprise, surprise. I'll help you guys set this one up, and then I'll leave you guys to try the work, okay? So a liner is leaving a port, P, somewhere here, with all the sailors there, and it sails 15 kilometers on a course of 37 degrees. So from the port, I'm going to draw north. That's going to head off, boom, 37 degrees, okay? To position Q. So we'll call this Q. It then changes course to 270 degrees and sails 12 kilometers to position R. So I'm going to draw, there's north again. Now 270 degrees is 3/4 of a circle. So that's actually going to come around like this. And it's going to go straight across. Okay, 12 kilometers. This is 15 here. Now we wanted to calculate the distance you must sail from R to P. That we don't know. Okay, so it's going to look something like this. So what we need to do is we need to calculate, we need an angle, or we need something here to calculate this guy here. Since this is a cosine lesson, I'm guessing we're going to need to find this angle here first, and we can do that actually by using some simple geometry. Now these two lines here are both parallel, so that means if this is 37 degrees here, with alternating interior angles, I know that this is 37 degrees. And since the ship went due west at 207 with a bearing of 270, this whole thing here has to be 90. So if this is 37, 90 take away 37 is 53. I now have the angle. Okay? So it's just working with some parallel line stuff. Hopefully you guys remember that from Foundations 20, or you did take Foundations 20. Um, but otherwise, yeah, it's just some basic parallel line rules there. Now we can go ahead and solve this. So I would know that my x squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine 53. So if you work that all out, I'll give you a second to try that. I got a distance of 12.3 kilometers. All right, so that's how you do cosine law. Hopefully it makes sense, guys. Here's the assignment, and good luck.